Hi, I'm Craig Uranic, and I would like to do problem 3 from section 2.2. Let's go ahead and read it. The number of rushing yards per year by Ricky Williams of the Miami Dolphins has decreased approximately linearly from 1,853 yards in 2002 to 15 yards in 2007. Let R be Williams's number of rushing yards in the year that is T years since 2000. Find the equation of a linear model to describe the data. To find the equation, since we've been given 2 points, I want you to do it by hand. So that's how we're going to do this problem. So if we're going to create an equation that represents this linear model for this situation, and if we're going to do it by hand, we need two ordered pairs. What most people do is they look and they see, 1853 yards in the year 2002. And so they'll put 1853 here. And of course, you don't put 2002 because you can see in the problem that it says since 2000, so we'll adjust that 2002 into a 2. Now, the 1853 represented the yards rushed, and 2002, or the 2, represented the year that he rushed those yardage. Now, when you do ordered pairs, which comes first? Well, the x does. And the x is the independent variable. The second one is the y, which is the dependent variable. And starting out like this would be wrong. Let me show you why. Let's take a look at which the independent and dependent variable is. Let's just start with r. Remember, to figure out if r is the dependent or independent variable, we ask the question, does r depend on the time, which is year, which is the year that it rushed? Well, yes, the rushing yards depend on which year we look at, or the t. Well, that means r is the dependent variable. Well, the dependent variable is represented by the y. So this is incorrect. We should have put the t first, which is the independent variable, and we should have listed the rushing yards second, which is the dependent variable that goes with the y. So let's go ahead and start over. So the 2 points we will be using will be 2 in 2002, which represents the year or the time, and 1,853 yards in that year, which is represented by the variable r for rushing yards. And then in the year 2007, which adjusted to 7, he rushed 15 yards. So to find a equation that goes through a linear equation that goes through these 2 points, we will use the standard form of the equation of a line, which is y equals mx plus b, where m is the slope, b is the y-intercept. So our goal then is to find 2 things, to find the slope and the y-intercept. First, we'll start out finding slope. We know that slope is the rise over the run. Or another way of saying that is it's the change in the y values over the change in the x. And mathematically, when you have 2 points or 2 ordered pairs, the way you do that is y2 minus y1 over x2 minus x1. All that's saying is subtract the y's over subtract the x's. Our y's, of course, are the r's because that's the dependent variable. So I will start out subtracting 1853 minus 15. I like to start out with the biggest y first. It doesn't matter which one I start with. However, once I start with this point's y, I have to start in the same point with the x. So I would not want to go 7 minus 2. I have to start with 2 minus 7. And this would give us This minus this is 1838. You can use your calculator. And 2 minus 7 is a negative 5. Well, notice that makes sense because this person had said reduce their rushing years, or how did they say it? Has decreased approximately linearly. And so therefore it has decreased each year, so the slope would be negative. And we end up with, if you use your calculator and divide this divided by negative 5, you end up with negative 367.6. Well, that's part of our equation. That's the slope part. Let's go ahead and circle this. So now we have part of our equation. We have y equals negative 367.6 x plus b. So our next goal will be to find the y-intercept. How do you do that? We have 3 unknowns right now, but we do know an x and a y, and if we put those values in, then we'll have one unknown we can solve for. So I will substitute, doesn't matter which equation I use, this one has the smaller number, so I use this one. I'll substitute 7 in for the x, rewriting everything else the same. And I will substitute the 15 in for the y. So, to solve this, we would multiply these two first, which is negative 2,573.2. I already did on my calculator, so you wouldn't have to wait for me. We would add this to both sides, so that would essentially cross that one off. And I'll add 2,573.2 on this side. So we end up that b is equal to, add those together, you get 2,588.2. So there's our b. So that's enough information to give us the equation. We have the m, we have the b. Therefore, the linear equation that models this situation will be y equals negative 367.6 x plus 2,588.2. However, the back of the book will not have that. They will be using different variables. Don't forget, our variables for the independent variable was a t, and the dependent was r. So t will become x. So I'm going to change that to a t. And the second variable, the y variable, the dependent variable, the yards rushed is an r. So I would switch that to an r. So there you have the equation. R equals negative 367.6 t plus 2,588.2. So there you have it. Problem 3 from section 2.2. Thank you.